Welcome students on today's lecture on design of tension members. So today we are solving a numerical on finding out the tensile strength of the plate member. So this is the numerical which I have taken for today's lecture. So I read it the question. Determine the tensile strength of the plate member 150 by 10 mm connected to the gusset plate using 6 number of bolts of 18 mm diameter property class. Take pitch equal to 60 mm and edge distance equal to 40 mm. Now this is a analysis numerical wherein all the data has been given. So what is the first main component? To find out the tensile strength of the plate member. So there are plates, it is a connection between the plates. So the plate of 150 mm by 10 mm, that is this plate is connected to a gusset plate. So these are the two plates and the connection. How are the connection made? By using 6 number of bolts in 2 rows now. So 6 number of bolts 1, 2, 3, 4, 5, 6 provided in 2 rows. So let us see the given data. So first I have written here pitch 60 mm, edge 40 mm, area of the plate is that the consideration, that is 150 into 10 mm. So we got the area. Now let us see how to give the dimensions to the members or the bolting systems. Now this is the edge distance. So edge distance is given 40. So the first bolt is placed at a edge distance of 40. Then we have pitches in between the bolts 60 and 60. Now what about the vertical side? Say for example this vertical side. So this plate is of 150 mm by 10 mm. The meaning of this is this total from here to here is 150 mm. So if this is the bolt system, so in this width, that is 150 mm, 2 bolts are present. So in any case we should provide the edge distance. So what I did, so 40 mm from below side, 40 mm from above side. So out of 150, if 40 is and 40, 80 is gone, so remaining is 70. This is how we arrived at a distance of 70 mm. So this is the data which we have got. Now let us find the tensile strength of the plate member. Now as per the IS code IS 800-2007, we will see here. So the tensile member, so the tension strength is given by 3 components. One is strength due to yielding, one is rupture strength of critical section and the block shear. So let us start with yielding. So design strength due to yielding of gross cross section as per clause 6.2 is given by TDG is equal to AGFY divided by gamma m naught. So this we have written it here. So the total tensile strength of the plate due to gross yielding is given in clause number 6.1, page number 32 of IS 800-2007, which is given by TDG is equal to AGFY divided by gamma m naught. AG is nothing but the area of the plate member. So it is 150 by 10 1500. So that what we have written it. So area is 1500 mm, that is 150 into 10 into Fy is 250 Newton per mm square, and gamma m naught we will get from table number 5 of IS 800-2007. So after computing we get the value of TDG as 340.909 kilonewton. So this is the strength due to gross yielding. Now next, second, tensile strength due to the rupture of critical section. Now in this we have 2 components. The first 6.3.1 is for plates and 6.3.3 is for angles. So our numerical consists of both the plates only. So we have to take a formula for the plates. So the design strength in tension of a plate TDN as governed by the rupture of net cross section area AN is given by TDN is equal to 0.AN FU divided by gamma m 1, where AN is the net effective area of the given member. So same has been taken here. So the design strength due to rupture of critical section for plates, remember it is for plates. So design strength in tension TDN is given by 0.9 AN FU divided by gamma m 1. Now AN, net area, how to compute it? Let us see the diagram first. So we have the bolting which is a chain bolting system. So let us take this as the section, and let us take, however there are 2 bolts in width, so I will take this as a critical section, say this as a critical section. So section say 1 1, and the total width of the member is this 150 mm. So we are now considering this strip wherein 2 bolts are there. So how do we get net area? It is nothing but width, that is width into thickness, that is this section, minus of this bolting system. So let us see. So net area is given by B minus N dH into T, where N is the number of bolts present in that critical section, dH is the diameter of the bolt hole, and T is the thickness of the plate. So B works out to be 150, and N, this is a section considered, and we have here 2 number of bolts. So B is 150, N is number of bolts 2, and dH. So however the property, the diameter is 18 mm, so the diameter of the bolt hole will be 20 mm into T. So this is how we get the net area. So AN is equal to net area B minus NDH into T. So for this section it is 150 minus number of bolts in a critical section 2 into the diameter of the bolt hole 20 into 10, we got 1100 mm square. So after getting this AN, let us substitute in this and get the answer. So TDN is equal to 0.9 1100 into 410. Fu is maximum strength of the member. So which is the member? Plate. So the strength of the plate is 410 divided by gamma m1, which we will get from the table number 5. So 1.25. So this works out to be 324.720. Now the third component. So we have got the answer for design strength due to yielding and design strength due to the rupture of critical section. Now next, design strength due to the block shear. So this is given by the block shear strength TDB of the connection shall be taken as smaller of. So there are 2 formulas here. Whichever is the smallest of the 2 is the TDB value. It is on page number 33 of IS 800 2007. So this same thing I have written it here. So block shear strength from clause number 6.4, page number 33 of IS 800 2007. So this is the formula. So TDB1, I have made it as 1 and 2 because there are 2 formulas. So AVG Fy divided by root 3 gamma m naught plus 0.9 ATN Fu divided by gamma m1, and the other is TDB2, 0.9 AVN Fu divided by root 3 gamma m1 plus ATG Fy divided by gamma m naught. Now in this, what all we know? We know Fy, that is yield strength of the member, that is 250 Newton per m square. We know gamma m naught from table number 5, it is 1.1. We know Fu, which is 410 Newton per mm square, ultimate strength of the plate, and gamma m1 we know that is 1.25 from table number 5. So what are important components which has to be found out are AVG, ATN. Similarly in this also we know Fu, we know gamma m1, we know Fy, we know gamma m naught. So we need to find AVN and ATG. That's what has to be computed. How do we compute? We have to consider it that the plates are failing in a block shear. So this is how the diagrams look like. So initially I have, this is the diagram which we had, the same thing we have drawn it here, and these are the dimension which has been taken up here. So this is how 6 bolts are placed, okay. And this is the distance is marked. So this is edge distance 40, this is pitch and pitch. Here also we have edge 40, so remaining is 70, so this is dimension. Now how the member will fail, I have drawn it here. The member, after the pulling force, tensile force is applied, the member will fail like this, and this is a block which will get prepared. So after failure, this member looks like this. So now we have 2 components, that is AVN and ATN. So the components N and T, N and G represents to net and gross. Now important is this V and T. So what is this V component? Whatever coming in the direction of the force, that is parallel to the direction of the applied force, has contributed to V, and the perpendicular to the applied force has contributed to T. So let us find out the distance. So what is LV? LV is nothing but the distance from the edge till where the failure has occurred, that is from this end to this end. If we can see in a clear idea, we will get here, because however it has failed and this part has gone. So, that distance is LV. So, how much it is from here to here? That is nothing but edge distance plus 2 pitches. So, LV is equal to 40 plus 60 plus 60, which is working out to be 160 mm. Now, regarding LT, now this numerical is having bolts in 2 rows. So, this is how it fails. So, this is the LT distance, which will be perpendicular to the applied force T. So, this is the LT distance. So, if you see, LT is nothing but 70 mm. Now, let us find the areas of the cross sections in the parallel direction as well as the net sections in the parallel direction, and the areas of parallel direction for the net sections and areas for perpendicular directions for the net section. So, let us find out the gross sections first. Let us say AVG. So, how is AVG given? This is gross, that means without deduction of the bolt holes. So, LV into T. LV is a distance 160 into T is the thickness of the plate 10. So, 160 into 10 works out to be 1600 mm. So, this is the distance LV. But if you can see, when the failure has occurred, so it is not only just one LV, even we have here this also gets cut. That means this portion gets cut. So, we have 2 lengths of LV. So, multiply by 2. So, here I mentioned clearly 2 lines parallel to the force. So, force is going on. So, this is one LV distance and this one is the another LV distance. So, multiplied by 2. Then coming to ATG. So, cross in the perpendicular direction. So, it will be LT into T. So, LT is 70 into T. Now, this has only one section over here. That is why 70 into 10, which is 700 mm square. Now, let us calculate the net portions of the areas. So, AVN in the sense net area for the forces acting parallel to the applied force. So, it is nothing but LV into T minus bolt hole diameter into the thickness. So, already we have calculated LV into T, that is this here 3200 minus. Now, let us see, this is bolt hole diameter in that section. Now, in this section, if you happen to see how many number of bolts are coming into action. So, this is one number of bolts got cut, this is second number of bolt cut, and this is third. So, if you see in this direction, so this is considered as 1, 2, and this only quarter is gone, that means 2.5. So, this is number of bolts in a line 2.5 into diameter of the bolt hole. So, this diameter of the bolt hole is 20 into the thickness 10. Now, why 2? Because we have 2 lines here. So, multiplied by 2, 2 lines parallel to the force. This can be also written as like this also, 1, 2 and half, 2 and half, then half, 3, 4 and 5. You can write it 5 also here. So, I have considered, however, I have taken here also a single line. So, I am multiplying with 2 for the 2 parallel lines of forces. After calculation, we get this as the value, that is 2200 mm square. Then next let us calculate ATN, which is nothing but this component LT is there. So, multiplied by T. So, LT into T minus bolt hole diameter into the thickness. So, 700 we already calculated minus. Now, how many bolts are coming in this direction? So, this is getting in quarter cut, this is quarter cut. So, we are considering it as half and half. So, half plus half is 1. So, this is number of bolts, this 1 is number of bolts, which is nothing but 0.5 plus 0.5. So, 1 into the diameter of the bolt hole into the thickness. So, we got this. After getting these 4 values AVG, ATG, AVN and ATN, we substitute in the formula. So, this is the formula as per the codebook. So, we substitute in this AVG, ATN, AVN and ATG and other components, we substitute and get the answer. So, we substitute, after substituting we get TDB1 as 567.491 and TDB2 as 534.045. So, which is least among this? Because we can clearly say that block shear strength is the least of TDB1 and TDB2. So, the least out of this is this one. So, TDB is 534.045. Now, we shall compute what is the tensile strength of the plate. So, the tensile strength of the plate is given by least of TDG, that means gross yielding, TD and due to the rupture of the critical section, TDB due to the block shear. So, let us see what are the values. So, in TDG we got it as 340.909, TDN we got it as 324.720, TDB we got it as 534.045. So, we can clearly see that the least value is working out to be TDN's value, that is 324.720 kilonewton, that is 324.720 kilonewton is the tensile strength of the plate. So, this is how the numerical has to be solved. And what is the meaning of this is, now this has failed in this criteria, that is TDN is the least value. The meaning of this is the member will fail in the rupture, that is rupture of the critical section. So, one of the section from the plate direction whichever we have considered, it may fail. So, this completes the numerical on the tension member. So, to all my students, so be safe at home, be home. Thank you one and all.